Welcome to the War Eagle Radio, where we talk about the Auburn University Formula SAE team. My name is Payson Williams, and we bring you this every 2 weeks and feature members of the team to talk about our design process and goals. We want to give little insight into the design process and tell everyone what's going on in the shop. Today we've got Kyle Kubik, the lead chassis division engineer, and Joe Stitt, the lead powertrain division engineer.
Hey everybody, this is Joe Stitt. I'm the 2016 Chief Powertrain Engineer. This is my 5th year on the team. In addition to being in charge of everybody under the powertrain group, I myself am personally responsible for doing all the engine simulation and the engine calibration and testing and a little bit of the physical engine work.
Hi Joe, I just have a few questions lined up about the powertrain team. What are we using, and are there any modifications planned for our engine?
Being that we're keeping with the same monocoque shape kind of limits our engine choice, as it's designed for the Yamaha R6. So still with the same engine. It's going to be the 5th year, I believe, with this engine. And we're going to try and keep with the same standard modifications that we've always done. You know, custom cams, custom cam timing, compression ratio, weight reduction on the inside with a knife edge crank and removing 5th and 6th gear. And then we're also going to try and do some investigations with engine polishing and maybe engine coating to try and reduce friction and increase our mechanical efficiency.
Now, what can we expect in terms of this year's performance?
At the very least, the engine performance itself will be relatively the same to last year. 82-ish horsepower minimum, about 43 foot-pounds of torque minimum. But again, as we've found that past years, it's not really all about how much power and torque you make. It's about where you make the power and torque and how you get it down to the ground.
Last year, we switched to an electronic throttle control. Are there any drawbacks to a mechanical system versus an electrical system?
The main drawbacks for the electronic system is that the throttle body itself weighs a lot more, but then again it's a wash because now you don't have a heavy steel throttle cable and a super complex throttle pedal assembly for that. But obviously, with a lot of electronic components, you have to make sure that everything's working. Within the rules, there's a lot of checks and balances that we have to make sure our car can actually run with electronic throttle. But the benefits of electronic throttle definitely outweigh the additional complications that we have. For example, we can have our pedal map be based on torque output, so if the driver asks for 10% more throttle, he gets 10% more torque. And then additionally this year we're going to start investigating using electronic throttle as another parameter for traction control.
Leading away from the engine and more technical talk, how are you leading your powertrain meetings, and what are your expectations for your team?
Powertrain meetings are a little different this year. We're trying to make all of our meetings a lot more technical. Each week, every designer, including myself, will have to come with a weekly presentation just saying, hey, this is what I worked on the past week. And it helps us make sure where everybody's at in their design process. And then also forcing them to do that is sort of documenting their design so that way future members can see how to go through design in general. And then also it sort of helps prepare people for, going through the design process. When they actually get to the design competition at Michigan or Germany or Lincoln or wherever, they're already used to presenting in front of people. So they have everything laid out in front of them because they've been documenting it, and then it just comes natural to them. So design meetings, because of this, have gone a little bit longer, an average hour to an hour and a half. But overall, for the team benefit, it's definitely worth it. As far as my members go, same standard we've always had on this team. We keep all our designers to a very high standard because this is a program that we're very proud of. By keeping our designers to a very high standard, making sure everything's documented, making sure everything's properly tested and validated, and making sure every decision has a great engineering design reason behind it, we think we're going to create great engineers because of it.
Thanks, Joe, for coming by and answering my questions. Now, if you were here last week, you remember Jonathan talking about being a data-driven design team. And Joe really just outlined what he expects for his team, and that really shows our new team dynamic and what we're trying to accomplish this year. Moving on to the chassis side of things, we have Kyle Kubik, the lead chassis engineer. Now we're going to move on to Kyle Kubik.
Hey everyone, I'm Kyle Kubik. I'm the chief chassis engineer for the team. I've been on the team for 4 years, and I also am the head of the vehicle dynamics sub-team.
Hey Kyle, so I just have a few questions about vehicle dynamics and the suspension and aerodynamics, really, since you're in charge of it. What are your design goals for this year, and do you see any complications with aero?
So a big goal for this year was actually the integration of aero with the rest of the team and the team's philosophies. A lot of our goals have been focused around that. One such goal is we want to keep the car the same weight that it was last year. We're shooting for a goal of 410 pounds for the overall mass of the car. That means that a lot of sections need to focus heavy on reducing weight so that we can integrate the wings without a significant performance penalty to the vehicle. On top of that, we've been doing a lot of look into fatigue life calculations as one of our goals. We want every member of the team to have an idea of how long they want their components to last. Using that and some data, we can figure out how stiff we need to make our parts and how strong everything needs to be in order to make the lightest possible components that still meet all of our safety needs.
Now, who is testing these parts?
So we've got a lot of engineers working on some physical testing throughout the design season. Drew Campbell is one such engineer doing a lot of the physical testing for the composites in the monocoque. Then Nathan Baker is also doing a lot of good testing on the new composite links that we've been experimenting with.
Are there any complications with Aero besides immediate ones that you can see in the foreseeable future?
So the thing about Aero is that it's sort of one giant complication. So in order to really meet the needs of an aerodynamics package, you need to sort of hinder yourself in other areas. The vehicle dynamics, for example, needs to take a hit in its transient controllability because the aerodynamics does not like pitch or roll in terms of its efficiency. So we sort of need to do a lot of analysis on how much we can give up in other areas in order to make aerodynamics the best that it can be.
Are you leading the team meetings that you have for the chassis division in sort of the same way that Joe is?
Yeah, so a big push for the team this year was design documentation and just sort of proper design process in general. So we've sort of gotten together and we've decided to run a lot of our meetings the same way. All of my engineers present a report every week. They build their ability to sort of communicate their designs as well as their ability to document themselves.
Well, that's all I have for today. Thank you for listening, and I hope you tune in the next 2 weeks for our next podcast. Thank you to all our sponsors, supporters, and family members making this possible.